Okay, and I think we are ready to start. Thank you so much, everyone that has joined, and there will be some other colleagues joining as well. Thanks a lot for being part of this public webinar of the Neutralpath project. We're going to have the example and the journey we're going to learn from Ghent's actions on PCEDs, on positive and clean energy districts, and the pathways and challenges we're finding within the whole project for replication. We'll hear a little bit about it. I just want to introduce myself first. My name is Carlos Montalvo. I'm Senior Project Coordinator of Eurocities, part of the Neutralpath project, and we have supported the City of Ghent, which I will introduce in a bit, together with Hermione Hadrisa Michael, part of Eurocities as well, that has been supporting also this project for quite a while ago, a couple of years, that we've been putting together a lot of effort to support these cities. We have a very packed agenda. We will hear from the project coordinator of the Neutralpath project, Cecilia Sanz, in a bit about what is the bits and outs of the project. I just wanted to remind everyone that this meeting is being recorded. So for the ones that are not present, if that's okay with you, so we can have your permission. We will then hear from the City of Ghent, from Roland Kiersmakers, the City Project Manager of the City of Ghent, on the introduction of the Living Lab and the case study or the breakthrough project of Ghent. We'll hear also from more of a technical perspective on Hannelore Kuipers from the University of Ghent on the technical insights and a case study deep dive. And then we'll go back to Roland with some governance and strategic insights. Then we'll open up the floor to questions, where we'll try to benefit the most from the great example of Ghent, and also from what curious to know what your cities are doing, what you're doing as an expert, or just curious to know what these positive clean energy districts mean and could be helpful for the areas that you work with or live in. So without further ado, I will introduce Cecilia Sanz, the project coordinator of the Neutralpath project from Cardiff. Cecilia, the screen is all yours. Thank you so much.
Thank you, Carol, for the presentation. I'm going to share my screen. I think you are able to see it. And as you have introduced, I'm the coordinator of Neutralpath project, working in Cardiff Technological Center, and I'll give you an overview of the project, what is the objective of the project, and the framework in which we have Neutralpath. We're faced with Neutralpath, a large-scale demonstration project. It's a collaborative Horizon Europe project, and the aim of Neutralpath is to demonstrate that the positive and clean energy districts works for helping our cities to achieve the climate neutrality. So our positive and clean energy districts are designed under participative concept and in a clean way. And this is would be the main objective we have during this 5 years project. 25 partners from 7 countries, and we have to focus, as all demonstration cities demonstration projects, we have 2 lighthouse cities where we in fact deploy these positive clean energy districts. In our case, these lighthouse cities are Dresden, Germany, and Zaragoza in Spain, and with 3 fellows that works closely with these lighthouse cities into the neutrality of the cities. In this case, our Vanta in Finland, Istanbul in Turkey, and in our case, Ghent in Belgium. So these are the activities. What is a positive and clean energy district? It's a part of the city that produce more energy than consumes. And of course, this energy it's obtained through clean energy solutions. We have to different energy renewable resources, and we combine storage and energy flexibilities for providing this surplus. And this surplus can be used by another part of the city and in global, they have more neutral climate city in our case. This different solution, or the panel of different solutions are being tested in Barcelona and Dresden, and in Zaragoza, sorry, and Dresden. And we will have different aspects of PV panels, geothermal energies, or different installation solutions for the different buildings. We work with private buildings, residential and tertiary ones, and also public buildings, and working in the energy grids that we have in our cities. So with this, or from these different solutions we implement in our Laja cities, our fellows adapt some part of the solution, or learn about what we have done in the different cities. So we have 5 cities working on these objectives, and now today we work, or we are going to focus on the activities of Ghent, one of our most advanced fellow cities, and that will be explain what is done during the project in these aspects. So thank you for these questions, and now I let you to know more about Ghent solutions and how they are facing these activities in Neutralpath.
Thank you so much, Cecilia, for showing us and reminding us the relevance of the PCEDs, the Positive Clean Energy Districts, relevance for climate neutrality, and also showing us some examples on how we're doing collaboration with the cities, but also, and we will hear from this. And I'm seeing also a lots of colleagues also joining from other projects and other initiatives, and we're really happy to share these insights that we will get now from the City of Ghent. So to focus a little bit on the how, we will introduce our colleagues from the City of Ghent. But first, they have prepared, and we will facilitate a little bit of questions for you to know a bit on the scale or the reach of the knowledge that we have within this audience right now. So I will ask you, please, if you could get your phones out, get your phones out, scan the QR, and get it there to participate and see how we can respond to some of the questions together. So I will do this also. So I'll just, or you can join there. Just Hermione just shared also the for the ones that can wanna do it on their computers as well. So just a couple seconds for having more colleagues to join. And I think, Hermione, you can share, thank you so much, the screen to start with these questions. And whenever you're ready. Okay. What best describes your background? So just wanted to know a little bit about the diverse audience that we have today. So if you're coming from the private sector, if you're coming from a specific project, if your backgrounds come from more a technical side, from engineering, from social studies. So we would like to know a little bit about that. Okay, we have energy researchers, we have EU policy on local energy transition, public administration, building physics, urban planners, engineers, architects, research associates, quite of a mix, which is one of the key components of delivering successful projects in general, but specifically when we talk about these more granular scale at a district and neighborhood level, it's something that it's really, really, really important. Doctoral researchers, business innovation expert. Business is something that's really important as well. And we will hear a little bit more about that with our presenters right away. If we can pass maybe to the next slide, please. Yes. How familiar are you with energy positive or climate neutral districts? Do I have a bare idea? I'm an expert on this. I really know, and I can contribute a lot to the discussion that we will have, of course, afterwards. After the presentation, I'm familiar, I'm not familiar, I'm extremely familiar. We would like to see from your backgrounds also your, let's say, level of knowledge from this. So we can see now that we have an audience that knows. At least we know that we're going to have a lot of questions. That's great. And of course, with those questions comes the reflection, the collective reflection of how we can, in a way, suggest also new methodologies, new tools to what the City of Ghent is doing. We are more familiar than we thought. For the next question, which of these energy solutions have you heard of? Heat pumps, district heating, solar energy, energy storage, none of these. Okay. Shall I press none of these? So there is like a mix of. So there's different solutions, as I was saying, also methodologies again that go with these different solutions. There's also the governance aspect of it, not only the technical solutions, and those are the ingredients that we will mix with this mixed audience for these presentations. Maybe we can go to the next one, solar energy. It's been the first one, huh? How would you describe energy costs in your country today? That's a very good question. Are they affordable? They're extremely high and we cannot afford them. I really don't know. Maybe that could also be an answer. They're increasing, but manageable is going up. In the geopolitical context that we're living right now, energy, it's being more and more, of course, expensive, and it doesn't seem like the landscape will change soon. So that's also a very interesting layer, an interesting variable to put down, or let's say, putting the discussion of the trade-offs of the working with a smaller scale initiatives, like the one that we're going to discuss today. Increasing but manageable is the one that it's taking the high stakes today. Maybe the next question, please. And who do you think mainly manages district heating systems in your country? So who's the one, let's say, in charge of district heating in the countries that this audience is coming from? It's either the municipalities, it's private companies, it's a mix of both. It's could maybe also in a case be a strong, let's say, a strong decision or a strong framework coming from another regional level of governance as well. It's quite interesting because within different countries we have different setups and different frameworks, and it's interesting to share these and to understand with the different scopes also the specificities that could help one country or one city or the other. So we see that it's a mix of both. I think, do we have another question maybe? Yes. What kind of work or activities are you involved in this related topic? It's either you are working on a specific project, you are working on a tool, on a solution, on case studies, maybe if you're researching on this. Again, a methodology. If there's something that you're really working in and that you would be also interested in sharing at the end of the conversation that could contribute to this. We have one answer, small scale PCD. But I think we are going towards, or maybe really curious to know about Ghent. Research on clean heat uptake and gas decommissioning, energy simulations in support of research projects, co-developing PCD pilots with landowners, energy optimization. So these are, again, ingredients and parts of a big comprehensive, would say, challenge first, and then opportunity and project. So we will now, thank you so much for being so interactive and dynamic with this. with this introduction that you have made, and thank you for contributing to this. We will continue, and I will just give the word to Roland and Hannelore that will guide us to the journey of Ghent with positive energy districts. Thank you so much, Roland.
Thank you for the introduction, Carol. So now I try to share my screen. And I will start with an introduction to the living lab we set up in Ghent, and also the case study of the district Maden-Meulenstede. I'm, by the way, Roland Keersmakers, working for the City of Ghent as a policy advisor on fossil fuel-free districts. And as the City of Ghent, we are the second largest city in the Flemish-speaking part of Belgium. We have around 280,000 inhabitants and very dedicated to become climate neutral by 2050, as you see in this slide. This slide is one page of our climate plan. We have already made three climate plans till now, and the fourth climate plan is in the making. As you see, we already in 2009 signed the Covenant of Majors, but the figures that are mentioned on this slide has to be corrected, because in the following climate plan we will also become more in line with the Europe Fit for 55. Still now we say we will reduce 40% of our CO2 emissions, but now we are aiming at 55% reduction by 2030 to become in 2050 climate neutral. As you see in this slide, we have a lot of topics we're working on, especially on the energy efficiency of housing, and also the producing of renewable energy. In addition to the energy saving, local production and renewable energy is crucial as well. We wish to reach the highest possible level of energy self-sufficiency. Our aim is to cover 50% of our electricity and heat demand for households within local renewable sources by 2030 already. So if you see this slide, we have in Ghent 112,000 natural gas connections, of which 94,000 are from households. The majority of these households heat with natural gas. It's still a minority that heat with fuel or biomass. And in the total amount of this CO2 emissions from gas consumption for heating, the households are 1/3 of this total amount, as you see in the graphic. But now, when we are taking this graphic and see that till the year of 2021 we are on a good pathway. We are reducing our CO2 emissions, but for the coming years we are really facing a big challenge. And from 2025 already, all new construction projects must be gas-free. For the new built flats and large building projects above 5 units, this is already the case today. So the challenge we face lies mainly within the existing building stock. And that's why with our living lab in the City of Ghent, and especially in the district Maden-Meulenstede, we have started with an analysis of our current approach to decarbonize the existing housing stock. And as we look at this current approach, we look at the work of our one-stop shop, the Energiecentrale, which is delivering very good work by advising, also giving guidance and support to individual homeowners or landlords that want to renovate their houses. They put in place a lot of instruments that also are supported by the Flemish government, with financial incentives, also low-cost loans, also the EPC of energy efficiency labeling of these houses. But still, with this approach, we see that despite of now already different energy crisis, the number of renovations is hardly increasing. This is because I think for a lot of people, the cost is too much. The bill can amount up to 100,000 euros. And also, these instruments doesn't come always in the right hands. More than half of the energy saving subsidies goes to the highest incomes. So in the approach we are using now, you could say we are not taking everyone with us in the energy transition. And also, if you look at the tempo we had to make to become climate neutral by 2050, or to reduce the CO2 reductions with 55 by 2030, our tempo is too low. The CO2 reductions we realized between 2005 and 2021, they were mainly caused by higher energy standards for the new buildings, improvement in the energy efficiency in existing buildings, the decarbonization of the electricity and heating sector, and also by the higher temperatures during winter. And it is not because the renovation ratio is so high, it still remains around 1% of renovations every year. So that's why with our Living Lab we make another hypothesis, and we try to test even more collective approach on the basis of on the scale of a district is a better way to approach the energy transition. The Living Lab in the Living Lab Muiden fossil fuel free. We want to test whether the energy transition can be accelerated at the district level through the introduction of decentralized collective solutions. The existing or the known systems to make the built environment fossil-free, with individual heat pumps at the one hand and urban heat networks at the other hand, each have their limitations. They are not always efficient or inclusive, or very expensive and complex to implement. Decentralized sustainable energy and heating system solutions allow energy efficiency, production, and flexibility to be addressed simultaneously. Consider, for instance, a local field with geothermal drillings below that is used to heat several dozens homes around this field. The renovation of these homes must then be considered as at the same time as the implementation of the energy system and the availability of heat or electricity during the day or the year. Such collective systems allow the inclusivity issue to be included from the start. And these systems are more affordable in the long term. There are also opportunities then to link these collective energy systems with other domains such as climate adaptation, mobility or work, and the development and implementation of decentralized sustainable energy and heating systems solutions at the district scale requires a more integrated and cross-sectoral approach, which solutions that together cover the technical, economic, and social challenges associated with the energy transition and embedded in an overall urban development of redevelopment. This systematic, collective, and district-oriented approach increases the involvement, ownership, but also the acceptance of residents and various neighborhood actors. This was kind of the hypothesis we formulated at the start of our Living Lab, because we think if we want this more district-oriented approach, we need to put in place another level additional to the individual plot and the supra-local policy. We need to insert the level of the district, but also pilot projects. And that's why we organized a consortium around this Living Lab, because of the complexity and the the different challenges, like the social challenge, but also the technical, juridical, and organizational level. We bring together this consortium of partners, like Watson is an ESCO, SAMO is a social district organization, Kelvin Solution is a heat project developer, Energent is our local energy cooperative, Blixt is an expert in juridical questions. Daedalus Peuts knows a lot about building physics. Tridividend is more for the financial issues. And then we have a Neutralpath project partner, the City of Ghent, University of Ghent, Sweco also as a study bureau, and some umbrella organizations like Flux 50 and Vito. But with this consortium, we try to focus on one district. And the district is called Muiden-Meulenstede. We give now a short introduction and an idea, an impression of this district. In the photo you see, in the picture you see that it is surrounded with a lot of water. It's also very close to the harbor. In the north you see the harbor of Ghent, and in the north the city of Ghent. So it is a link between the city and the harbor. With this collection of pictures, you get an impression of the district. It is densely populated, a dense neighborhood with many apartment blocks and small houses with very limited private outdoor space. It feels spacious because a lot of water is around this district. It's kind of a peninsula. But there are a few shops and facilities for local residents. It has also a very young and diverse population with high unemployment rates. So that's kind of a reason why we choose as a city for this district to do this living lab, because there is a lot of challenges in this district, also a lot of vulnerable people. And we think if we can manage to implement this kind of project in this kind of districts, there is a lot of possibilities to upscale it to other districts of our city. Another reason to choose for Muiden-Meulenstede is also that there is already a strong social involvement of residents. Already in 2016, there were a lot of new developments taking place in this district. The city was making plans also for a real redevelopment of part of the district, and so residents asked to be involved in this process. So this was the starting point of a city renewal program that is called Muiden-Meulenstede Tomorrow. And from the beginning, residents are involved in this process. It also results in 12 agenda points that the residents themselves put on the table. You see them in the slide, but it's important to stress that the residents themselves, they formulated 2 agenda points that are very related to becoming climate neutrality. They want their district, Muiden-Meulenstede, to become a leader in achieving the objectives of the Ghent climate plan, and also they want to use the available space to develop, implement, and test concrete climate initiatives in the city of Ghent. So that gives you an impression of the district we are talking about, and that was my introduction for the Living Lab and also the concrete pilot project. Now I give the floor to Hannelore for more technical insights.
Normally you should see my screen now.
Yes, we can see it.
Yes.
Thank you.
Okay, perfect. So hello, I am Hannelore from Ghent University, a doctoral researcher on the project, and I'll give some info about the technical insights that we gathered from our case study, Muiden-Meulenstede. So first I'll go into the analysis of the case study that we made with the heat map and the typology. So first, the analysis has been done on a district level. So as Roland said, the district is a peninsula surrounded by water, and we looked at the entire district. So now we saw there that it mostly consists of 19th century terraced houses. There are also some apartments, but then further the industry or other public buildings are rather limited in the district. And as it is mostly workermen's houses close to the port area above it, there are relatively small houses with multicultural inhabitants due to the historical background of it. So the first thing that has been done is to map the heat sources and the demand to see if there is a balance that can be made in the district to serve as heating supply. So first, the potential heat sources that were figured out in the district are mainly aquathermal sources, because the peninsula is surrounded by water that can serve as a source for heating. And then also geothermal sources, so boreholes under the ground, and both public and private properties have been looked into if they can serve as a source. Then on the other hand, the heat demand in the district has been investigated. So it's relatively low. We saw that from figures that we received from Fluvius. So concerning the gas and electricity consumption in the district at street level is rather low. And it comes down to approximately 100 kilowatt hours per square meter, which is quite limited, although the installation rate is quite bad. But that is due to the typology. As I said, terraced houses and apartments, it are quite compact buildings with not a lot of heat losses. And then also the heating behavior of the people makes that the heat demand is quite low, because either due to energy poverty or due to climate awareness, they don't heat their entire houses. So not a lot of gas is consumed. And then on the other hand, there's not a lot of public buildings or industry, but there are some larger consumers as well, apart from the dwellings. So that is the heat demand and the heat source that we investigated. But then to combine both, there are also some implementation issues that you should be aware of. So because of the context in the district, we would first look into collective solutions like district heating. That is currently not present there. Everyone is heating with individual gas boilers. But then because of the small streets in the district, we're afraid that not everywhere district heating would be possible, because there are already a lot of pipes in the underground and there would not be space for the district heating pipes. But then if you go to individual solutions, you also have the problems of the heat pump acoustics when air-to-water heat pumps are installed with the ventilators outside. So that's also something to take into account in the analysis. Then going from the full district level, we decided to determine some project clusters. Heat is in the lead was one of the codes that was used, because the project clusters are defined based on the heat demand and the heat potential, the heat source potential. So per cluster, we searched for a balance between those two to have smaller clusters to work on that can be semi-autonomous projects that are small enough to be feasible to work on and that can be implemented, and that are not too large scale to be impossible to work on, but then also big enough to have impact. So we have still large enough project that can work as pilot projects that people can see what is possible, and that you have a big enough scale to have efficient collective systems. And then, of course, more detailed analysis is needed in these clusters, because the district scale analysis was quite big. But then when you fine-tune it, we come to these kind of maps. So this was one of the outcomes of the study. So per cluster, they investigated, for example, the preparedness for low temperature heating. So actually the light blue buildings are prepared for low temperature heating, but the dark blue buildings don't have a sufficient installation rate yet. Then locomotives and large consumers are indicated on the map. So these can serve as an incentive for a district heating system to make the business model more feasible, to have a large off-taker at once that is in hands. Some of them are in hands of the city, so we have something to say about it. Then also the potential of geothermal energy was investigated to see whether the bore fields, how far the bore fields could deliver heat for the dwellings. Then the width of the facades is a parameter to investigate the potential noise problems due to heat pumps. And then when putting all these maps together and all this information, we came to some definitions of proposed heat strategies per cluster. Then to go on a case study level. So on the map, you can see the case study we are working on. So it consists of a football pitch where we propose to put some geothermal boreholes under it to serve as a heating source. And then a district heating grid can be connected to the pipes and then can serve for the dwellings around the football pitch. And it would be feasible to serve approximately 230 dwellings with the heat that can be extracted from the geothermal boreholes. And then on the other hand, this collective solution will also be compared to some individual heat pumps without district heating. So to investigate then this solution, we had to do some analysis of the current situation of this case study and the dwellings there. So at first we have to investigate a typology of the dwellings. So it's these are the floor plans of the typology that we defined. So at the floor level, you just have an entrance hallway, the living room, the kitchen, and then on the second floor, also a hallway with the bathroom, and then two bedrooms. And then on the third floor, under the pitched roof, there are two extra rooms that can serve as bedrooms, as offices, as attic, depends on the household's preferences. So then the insulation rate is also investigated. So we did some house visits in dwellings surrounding the football pitch, and we estimated the EPC levels of it. It's not a fully accurate, detailed EPC assessment, it's more an estimation. But in general, we see that there's a low insulation rate. Most of the dwellings have insulated their pitched roofs, but like, for example, the facades are barely ever insulated. The windows are mostly double glazing, but not up to EPP standards. So it's not that good yet, but on the other hand, almost no insulation measures means that there are also no lock-ins. Like if you do the wrong insulation measures, it's sometimes hard to insulate the rest of the building. So that's not present there yet. So there is a large renovation potential. So everything can be done up to the EPB standards at once. And then concerning the heating systems, as I already mentioned, I think all dwellings almost have individual gas boilers. So not a lot of individual heat pumps are installed yet, which also has the potential then that the people can connect to the district heating without having invested in their own heat pumps already. So then I'll go into the fossil-free solutions that we propose for the district. So first comparing individual and collective, and then go into the heating behavior of people for a bit. So at first, yeah, the trade-off between individual and collective solutions has to be made. We had big discussions on it in the Living Lab, and in the broader context, knowing that it's an existing district with a lot of individual homeowners, no district heating solution is yet implemented. Then for the social part, I think Roland will go into depth more on that. But for the technical parts, these are the most important parameters to trade off when choosing between the systems. So at first you have the energy use or efficiency, which can differ. Like when you have large collective systems, the efficiency can be higher mostly. Costs will also be by Roland, but if everyone has to invest in their own heat pump installation, or you have a bigger installation, but then also the pipes of the district heating, that's a trade-off that should be made. Same for the environmental impact. And then for integration as well, it's also a trade-off because like when you have individual solutions, it takes more place than a gas boiler. So you have to put it somewhere in the dwelling, which is not always evident. But if you go to collective solutions, you have to have some place or, yeah, dwelling that can be used to put the entire collective solution, because it's quite big. And then also for the acoustics, if everyone goes individual, you have a lot of individual heat pumps making noise. If you have one big collective installation, you have one big heat pump making even more noise, but then it's concentrated and it's easier to do something about it. So everything there has been discussed, and then we came to some potential solutions that are summarized in this table. So 3 district heating scenarios have been investigated. So the first one is a very low temperature 5th generation district heating grid on 12 degrees. So then actually the concept is that the boreholes are installed and the water of the boreholes on that temperature are directly distributed to the dwellings, and then every dwelling has their individual heat pump to go up to 40 degrees for their space heating, and then to 60 degrees for their domestic hot water. But however, as it's a low temperature system, it means that the dwellings have to be very well insulated up to the EPDB standard. And as we saw, it's not the case in the district now, so that makes it only 5% of the dwellings would be able to connect right now. One big advantage of this system would be that cooling is also possible due to the very low temperatures. Then the next possible district heating solution would be a district heating grid on 40 degrees Celsius. It's still low temperature heating, but the temperature of the district heating grid is then sufficient for space heating. So the dwellings only need to increase the temperature for their domestic hot water, which can be done by booster heat pumps or an electric boiler, depending on their preferences. But also here, full renovation would be needed. So then a third option would be a district heating grid on 60 degrees, where only actually the windows and the roofs of the dwellings should be renovated because we have high temperature heating. This makes that already 75% of the dwellings would be able to connect because that insulation level is quite manageable. And then also for the ones that are not able to attach yet, the insulation measures that should still be taken are normally manageable to do. And another advantage is that the temperature is already high enough for the domestic hot water, so no extra booster or whatever is needed to do this domestic hot water supply. As you see, all those systems have their own advantages because the low temperature heating systems are more efficient, but then also more costly, more insulation measures are needed, while the 60 degrees heating grid is very convenient at this moment, but it's less efficient. So one of the proposals would be to start with a 60 degrees temperature grid, so a lot of dwellings can attach and we are fossil free from the start. And then we give the households like 20 years, for example, that they can insulate their dwellings. And then when everyone is insulated, we can lower the temperature of the district heating grids. After 20 years, also the heat pumps have to be replaced normally. So then we can go to more efficient low temperature heat pumps. And then it's like a stepwise transition where we're fossil free from the start, but the efficiency increases throughout the years because of more insulation and lowering the temperature. And then this district heating is like a collective approach. And then on the other hand, individual approach is also possible with heat pumps per dwelling, as individual heat pumps are really not efficient at 60 degrees. We also say like you have to insulate the full dwelling to go to temperatures of 40 degrees, but then also all dwellings have to insulate. So it's also quite expensive. And then in this case, when you have your individual dwelling, it supplies both the space heating as the domestic hot water. So you have one system for everything. So that are the collective solutions we propose. Roland will go more into the business model, the business proposal later. One extra slide I have is about the impact of occupant behavior, because it was also an important part in our research that was a big uncertainty, because as I said, the inhabitants in the district now don't heat a lot. Their heating demand is quite low because of their behavior, their heating behavior mostly. And this graph actually is a bit of a nuance on it, because as you see, the graph depicts the net heat demand per dwelling in kilowatt hours, which is on the y-axis. And then for 3 installation levels, so uninsulated as first, then renovating roofs and windows, and then doing a full renovation. The potential heat demands are depicted in the bars, going from the dark red, which is when you insulate your house 24 hours a day at 21 degrees, the entire house, and then going to the light orange, which is when you only heat 5 hours a day in the living room only at 21 degrees. And then you see that there is actually a big decrease in heating demand per installation scenario. As you see, for when you only renovate roofs and windows, there's up to an increase of 67% of heat demand, depending on your comfort preference level. which is a big difference. And for a potential business case, if you have to calculate it, it's a big uncertainty because you never know how people will behave. Because also, like the uninsulated part, if you really don't heat a lot and you compare it to the renovating roofs and windows where you do heat a lot, then you even consume more when you're insulated better. So that's something to take into account, because mostly when people insulate more, they go to higher comfort preference levels and their decrease in heating demand isn't as big as you would expect it to be, which has an influence on the potential business case. So that I also wanted to pass through. That's something to think about. And that would be the end of my presentation. And then I give the word back to Roland to go into governance and everything that he has to say. So, Roland.
Okay, thank you for this insight. This view on the technical insights. Now I will focus more on some strategic insight, but also the financial side of this proposal. Because of course we don't want only a district heating network that is technical, very feasible, but we want also a district heating network that can be realized, and there will be inhabitants that want to connect to this and can afford to connect to this network. So cost will be a main factor. So we have to think how to develop a heating strategy, and in this strategy, cost is a key factor. The total cost of the entire lifespan of the various scenarios, as already explained by Hannelore, but these various lifespans have a total cost, and this is the total cost of ownership. And the total cost of ownership analysis shows that the 60-degree scenario is the most cost effective for the homes around the standard murder zone. And that is because the investment in the energy installations, for instance, the geothermal drillings, the collective heat pump, the heat network, and also the operational energy costs to keep the system running, they are higher than in the other scenarios. But because the necessary renovation to connect to this district heating network at a higher temperature is significantly lower, the total cost for the 230 homes over 40 years is much lower than in the other scenarios. So it has to do with, like Hannelore also already said, there are a lot of houses that are already ready and to connect to a high temperature network. And then we can save these costs. Not only cost, but also the speed in which we can realize this kind of network is important. And opting for a collective heating network at 60 degrees is indeed the fastest and also the cheapest route to become fossil fuel free within an existing building stock. Individual renovations proceed slowly, yield in reality less energy saving than theoretically estimated, and prove to be unaffordable for many people. So if a collecting heating network at a higher temperature, you can say at first glance it is not a very effective or efficient system, but it can ensure that more people can join quickly. Then that translates into a CO2 reduction that is significantly higher over time. That a more intensive or extensive renovation will be still necessary later on to meet on the goal of climate neutrality. But as you see at the graphics of the picture at the left, we can drop down the CO2 reductions very quickly by installing a district heating network. And then we give, as Hannelore also mentioned, we give the people the time, 20 years, to renovate at their own pace. And then when the collective system and heat pumps had to be replaced, then we take the last step and switch the collective system from 60 degrees to 40 degrees. So in reality, in practice, this heating strategy will follow a transition path. To ensure that everyone has the opportunity to connect, it is important that the renovation offer is made first, with measures aiming at achieving level C. So it's like Hannelore said, the level where you renovate only the roof and the windows. After that, as many homes as possible will be connected to the district heating network as quickly as possible. And we can organize that in, for instance, 3 different connection waves in 2027, 2030, and then 2035. And during this first 20 years operational phase, the network will supply heat at 60 degrees. This gives residents the opportunity to gradually, at their own pace, continue renovating up to label A, so a higher energy efficiency. And when the collective installation is ready for replacement, after 20 years functioning, the system can be scaled back to a temperature regime of 40 degrees. So that's the heating strategy we have developed, not only from a technical point of view, but also from a financial point of view. Now we had to develop a business case. And the first difficult point we have to make is to determine an acceptable or a fair heating cost price. Currently, in Belgium and in Flanders, there is no policy framework in place for determining acceptable heating costs, like it is well in the case, for instance, in the Netherlands. Therefore, a methodology was developed by Kelvin Solutions for this pilot project to determine which heat price can be considered as fair, based on various reference frameworks. In the picture, you see the reference of natural gas. Which is the orange block. And Kelvin Solutions analyzed the impact of this heating cost on a variety of user types also located within the neighborhood. They see what is the heating cost of apartments versus single family homes, but also between the difference between new constructions and already existing homes, energy efficient versus inefficient consumer behavior. But today in the neighborhoods, a family average pays 140 euros per month for the heating and the domestic hot water. So ranging from 61 euros per month to 235 euros per month. This price does not include the initial investment cost of a gas boiler, but does include the investment after 50 years for a new boiler and the mandatory 2 annual maintenance cost. The sustainable alternative, which is in the green block, there is an air-to-water heat pump. It costs a family in the Muiden somewhere between 155 euros per month and 319 euros per month. This is by an average of 209 euros. Once again, the initial investments has not been factored in, but the replacement of the heat pump after 20 years and the necessary maintenance are included in this price. With a median disposable income of 20,000 euros a month, a year. That is the medium disposable income in the district Muiden is 22,000 euros per year. This amounts up to 6% of the disposable income for natural gas and up to 11.2% of the disposable income for the sustainable alternative for the residents in this district. This is high. Therefore, it is essential that there is a new policy framework that makes it possible to ensure that everyone in the neighborhood is financially able to connect to sustainable heat. We compare these prices now to the heating rates also to the Fluvius. Fluvius is our our distribution system operator, and they have also large-scale heating networks in other cities also one in Ghent, and they only manage at high temperature heating networks. Therefore, that is not really significant or relevant to compare it, because in the case of Standard Meulen, we have a significant energy use by the heat pumps that are installed. And that is the blue line you see. So we refer to these different frameworks to see what is a fair price we can ask for the heat that is delivered by the district heating network. So as we use these references, we see that per month the cost for a family in Muiden-Meulenstede amounts up to 209 euros per month if we take the average of the individual sustainable solution as a reference. This is higher than what many families today pay for gas. It's an average of 114 euros per month. Because gas is still cheap for the time being, and many people, especially the vulnerable people, are cutting back on heating or maintenance. However, within the current policies, the policy climate in Flanders, it is not possible to develop a sustainable heating solution that is cheaper than the current price of gas. To ensure that families in more vulnerable situations can also afford it, additional measures are therefore needed and to be put in place. Now to translate the total cost of ownership into an operational business model, we calculated the most cost-effective heating scenario, and we have to take into account the cost of upfront investments by external financiers, potential subsidies, the time-dependent distribution, and when revenues are received. So there are a lot of parameters we used to arrive at a viable reference business case. And you see there the different parameters we put in place. We see at the total cost for geothermal drillings, the power plant, the heat network, and the building connections, including the necessary investments. And with these calculations, the investment costs amounts up to 6.65 million euros. For the grants, we counted on a grant from the Green Heat Call from Flanders, amounting up to 30% of the investment amount. And the heat supply, we calculated heat per household per year about 11.3 megawatt hours. We are assuming a rate of 6% discount rate, which make the project attractive to potential investors. The electricity price, the current rate of the medium voltage power is approximately 220 euros per megawatt hour. And we calculated a term of 40 years. And it includes also the reinvestment of the replacement of the centrally located heat pumps after 20 years. The connection rate and pace in the reference scenario, we assume that 90% of the homes will be connected to the energy grid by 2035. The heat price that is not entered as a variable parameter in the business model, but we put a determined price in advance, as I showed in the slide before. We said we put this price at 209 euros a month, just to have the reference to the other individual sustainable solution. So with all these parameters, we come to the conclusion that the contribution that residents pays when their home is connected to the district heating network, we have to ask for a connection fee, and that connection fee will be in our business model 12,500 euros. That is still less than the investment required to install an air-to-water heat pump, which was estimated at 15,500. But still, there is a very high barrier to enter to the connection of a district heating network. So, as you already, I think, can assume, we are seeing in this kind of business models that there is a real need for public participation. If we only think in the market conform way, and we calculate the business model with a revenue and discount to feed for investors, then we have quite a high heating price we have to ask, but also the connection fee is quite high. So that's why we made a sensitivity analysis on this connection fee. And that then we see that there is a lot of uncertainty in our business model, because the investment can also be higher or lower than we now estimated. It can increase as a result of rising raw material prices or unforeseen technical problems, soil contamination, for instance, in the construction site. However, the investment can also decrease by taking into account potential synergies, such as to combine the district heating network with the reconstruction of sewers, road surfaces, or superstructures. Also, the subsidies are not sure. It can be more or less. The heat supply, due to additional renovations or new developments, the heat demand in the neighborhoods may rise or fall in the future. The discount rate is also not sure. And the electricity prices, especially in this kind of situations where there is a kind of energy crisis, it is also volatile. So changes in the electricity price depends on a lot of factors. In Belgium, we are waiting for a tax shift, and this tax shift could lead to a fall in the cost price of electricity. But necessary investments in the upgrading of the transmission and the distribution network will also lead to an increase of this electricity price. Also, the longer the duration of the model has an impact on the business model. But the most important factor or parameter and that will have an impact on the connection fee we have to count on is the connection rate and pace. As there are few in any comparable cases of district heating network to which individual existing homes are connected, estimating the expected connection rate and pace is very difficult. However, both depend on the large extent of the effort we spend in the supply and how policy responds to it. The sensitivity analysis examines the effect in these last two connection waves were to fail, leading to a connection rate of 70% by 2035. This parameter poses a very significant risk for the operator of the energy grid, and the levers to influence this parameter lies largely outside the sphere of the influence of the private party. A local or a regional authority can share these risks by focusing on intensive awareness raising and guidance, or offering a guarantee for the connection and payment of these fixed fees by, for instance, their own properties, the local authorities' properties. So that gives you an idea how complex such business models are and what risks are involved in realizing this kind of complex projects. So this is my last slide, and this calls for more public participation. Neither a private operator, a public utility company, or local authority, nor households themselves, they can shoulder the responsibility and the risks for the transition in their own. In theory, private parties currently bear the risks, Citizens are protected and the government facilitates the process. But in practice, private parties do not invest in neighborhoods with a low purchasing power, fragmented ownership, and social vulnerability. So the result is a structural investment impasse in collective heating projects. In Flanders, we do not have at this moment a framework for local authorities to share risks and roles with collective heating projects. Like many other Flemish cities and municipalities, the City of Ghent, therefore, is now fully engaged in navigating in this new landscape. To gain a better understanding of the various ways in which the city can share risks in projects like Standaardmeulen, there were 3 scenarios analyzed during this Living Up. In the first scenario, the city provides an occupancy guarantee. So if the jointly agreed reasonable occupancy level is not met, the city will cover the costs. So that's the risk the local authority or the city could take. Then in the second scenario, the city can also finance part of the infrastructure, like the pipes, the boreholes, or the network, and then grants a concession to the private operator. If the jointly agreed reasonable utilization rate is not met, the concession can then be delayed or cancelled. So in this scenario, the public authority or the city is an owner of the pipes. In the third scenario, the city invests capital in the project because a public authority has the possibility to give low-cost loans. And then if the jointly agreed reasonable occupancy rate is not achieved, then the cost of the capital, of the return that the city receives on the investment is reduced. So this potential impact of the different roles the city can take can be expressed also in 2 ways. The first way is that the cost price for the consumers is reduced by this risk-taking by the city. This is compared with the connection fee as calculated in the reference business case, 12,500. In concrete terms, if the city owns the pipes and expects a return only for 3% on the heating network and 0% on the biofield, instead of 6% that the private investor would anticipate, then the connection cost can be reduced with 30% or 3,750. If the city borrows 50% of the investments, that would be 3.33 million. At the interest rate of 2%, the connection fee can reduce to 40%. That will be then 5,000 euro connection fee. The other way to explain this risk-taking by the local authority is that the risk of under-uptaking is mitigated. In concrete terms, this means in the first scenario, if the city acts as a guarantor and only a connection of 70% is achieved, then the city pays 1% of the total investment per year to the private operator until the targeted 90% connection rate is achieved. In the second scenario, if the take-up rate is 70% instead of the targeted 19%, the city receives a return of 3% on the heating network and 0 on the biofield, instead of 6% if 90% capacity utilization is achieved. And in the third scenario, if the city borrows 50% of the investments and the capacity utilization is only 70% instead of 90%, then the city received an interest payment of 2% on that amount. So these are some directions we explored, some ideas of risk-taking by a public authority, and this was a lot of discussion, and I think it's also an interesting starting point for a discussion with other cities or other participants in this webinar. So I thank you for your attention.
Thank you so much, Roland and Hannelore, for having taken us through this very, very complex and rich example. The challenges that you've shared at the very end are, I think, they're shared with many of other cities and many other contexts as well. Not only, of course, in Flanders and in Belgium, but elsewhere in Europe. I just wanted to highlight this thing you started stating. It's that how do we do the inclusion of vulnerable groups and that are also in a way social involved within this project and taking everyone into this just transition. And I think as Hannelore mentioned also this using the phrase of heat is in the lead, right, for this subclustering of the design of the group, where the fossil free technologies, let's say, are the bit in a way, and the energy efficiency is the key to unfold this. All the challenges that in a way come down to the sort of how do we involve the stakeholders or the stakes of the private sector, the ownership of the city and the citizens as well, and how do we potentially ask for more subsidies to cover this, and the idea of how do you find out a sort of investment scheme that really works as a sweet spot for all of that you discuss is what I think we could focus now. So I have some questions on that, but I would love to open the floor to maybe any questions or suggestion, or just sharing an example from any other city that we would like to have, maybe coming from this scenarios that Hannelore mentioned, on more on the technical side, on using these 60 degrees framework that going then back to 40 whenever we have the renovation, but also on the business model within this capital discussion and the ownership of the city and the residents. Please, if there is any question, I see Masha. Masha, please. Very good to see you. Please.
Yeah, great to see you. I have many points, but I'll try to keep it limited considering the time. First of all, thanks a lot for this very interesting input. My name is Masha. I work at Agora Energiewende, which is an energy transition think tank. But I used to work with cities before, and I was colleagues with Karel. First of all, what I found very interesting is this heat vision and how you designed it. We have many other examples of cities who designed a similar vision. You know, I come from Vienna that has a very advanced heat vision as well, but very different governance and ownership structures that we face across Europe when it comes to DSOs. The case that you presented, it's very interesting that, you know, you explored all these heat sources, and you also mentioned, well, the gas consumption is relatively low. We're discussing with fluvius, etc. It seems like a low-hanging fruit to kind of start managing, kind of like managed gas infrastructure decline, because I was surprised when I was in another meeting of the Net Zero Cities that Fluvius was like, but where should we start, with which municipality, how to prioritize? This seems to be like a perfect case to prioritize, because, you know, like with all the solutions having an uptake, and I think gas will not become cheaper, even though it has been structurally low for the past few years, but I think we will face different times now. It could be a very interesting case to look at, you know, like what happens with all this gas infrastructure stranded assets, because this is a just transition questions ultimately. I mean, people who can afford actually will leave the gas network, and the fees will fall on fewer customers. The second point that I have, the timeline you mentioned for the renovation seems to be quite high. I understand where it comes from, but wouldn't it be the risk that, well, people would just replace a new gas boiler now in existing buildings and then be locked in for another 20 years in the fossil infrastructure if, you know, like things take more time? And maybe, and this is something that we're investigating now, technology, especially modern heat pumps, propane heat pumps that can function at higher degree temperatures, like at 60 degrees, could actually provide heat with the existing heating infrastructure to more households that may not necessarily require PB standard A. Nothing against PB standard 8, but we know, I mean, I live in Brussels, how difficult it is. And at the European level, it is extremely costly to do a blanket renovation wave. I mean, like if you do any number crunching, you need substantial public funding for that. And in some countries don't have the fiscal space. So it would be great to have some reflections on that. And lastly, the point on business models is extremely interesting. I think it's extremely interesting for many cities. I would also perhaps encourage more governments to look at the ETS2 front-loading facility that can be used for such solutions. Unfortunately, not many governments have applied, but EEB is now behind it. You know, like you have to use that money because ETS2, even though there is a delay, may eventually come. And then we're also discussing quite an interesting proposal about a heating and cooling facility that could also deal with a combination of grants and loans, de-risking funds over, you know, because this is a long time infrastructure. It needs kind of public backing, public guarantees, and access, of course, from local authorities to this kinds of funding that is crucial, even though it's managed by, let's say, the competitiveness fund under the new MFF. When Flanders designed national regional partnership plans, it could already include some milestones, you know, to include investments into clean heating and cooling, district heating, electrification. Thank you.
Okay.
Thank you so much for your questions and remarks, Masha. I think, Roland, maybe if you would like to draw on those, would be amazing.
First of all, on the suggestion of the new technology of individual heat pumps that can also manage to deliver high temperature. That's true. But what we are also learning from the Netherlands, where they're also trying to develop this kind of district heating networks in existing building blocks, that is, if people already change to the individual solution, it's also very difficult afterwards to get them back in a collective system. So that's one point. The other point, as Hannelore also mentioned, we have studied quite a lot with university, but also other partners in the consortium. What is the impact of these individual heating pumps in a very dense surrounding, in a very dense building block, and then we see that the noise is quite high, especially if you calculate also the accumulation of this noise at every as if there is at every home such a unit, it could be quite high. So that's why we are more focusing. That's a second reason, and the third reason is of course the affordability. That's why we are now so hard working to realize a business model that makes the switch to fossil fuel free options accessible for everyone, also the vulnerable people. And as you mentioned yourself, if we use the current approach, then there will be the people that have the financial capital and also the willingness to change. They will go for the individual solution with air water heat pump. But afterwards, the people that can't follow this transition, they will pay off the assets, the gas network. So that's why we are so hard trying to make this kind of more collective network, although it sounds more complex. But I think, yeah, I think this is the first calculations we met. What we have learned in the last weeks, so it's not yet in my presentation, but in the last weeks we learned also that it's more interesting to scaling up this kind of project. So we are now talking about 230 homes, but it's even maybe it's better to make the connection to a double of these homes, so up to 400 houses. And also we are thinking about maybe to to make the heat price per month lower, even at the same level of the gas price, the natural gas price, and then take a higher price for the connection fee, because we can maybe create a fund or a loan or like we have already in Ghent an experience with the rolling phones. I don't know if you know the
I know
project
the rolling fund, yeah.
Okay, the rolling phone. So that then you don't ask from the people who want to connect the pre-finance this connection fee, but they only pay this back if their house is sold or something like that. So that's a long-term kind of loan we can also give, and then there is not so much barriers to connect to this district heating network. So there are still new ideas coming up.
Thanks a lot.
Of course, it's a work in progress, as you were saying, Roland, and thank you so much for giving us some details on this, and Masha also for all these insights and the opportunities that you've came across within your experience, and that could be also helpful for the next steps of this ongoing vision that Roland and Hannelore and the whole team at Ghent are doing. I just wanted to mention maybe Roland or Hannelore, you said there was no policy framework. I was just a little bit curious about, from one side, as you're exploring these scenarios where you, in a way, could build or could duplicate the amount of houses that you get into, in a way, leverage the amount of, let's say, make the technology more cheaper in a way for the people for the installation price, let's say. So to catch that, like get a bigger, let's say, stream of investment to make the connection or the participation or the access of the people more short, let's say. I was just curious if you're also, or what you have come across with your neighbors, for example, cities are near Ghent or others that might be also giving examples on that. I don't know if you could share a little bit of how's your strategy on that.
So in the actual framework, I think we have to work towards pilot projects, and then we have to land on subsidies. But on the longer term, we are trying to create, as I said already, we are trying to create more a framework that is sustainable on itself, and we have to scale up. So that's why we are now taking the initiative to connect to other cities. As you know, the EED, the Energy Efficiency Directive, they make it mandatory for the larger cities to make heating and cooling plants. And by this obligation, we try to connect these 19 cities in Belgium, in Flanders, the 19 cities and municipalities of Flanders. We are working towards a political session in the end of 2026. So our Elderman is taking the initiative to bring them together. Also, I hope with the Minister of Flanders, and then we are trying to create a larger scale. I think also in the other Flemish cities there are some pilot projects that are ready to be implemented, and if we can bring them together in one cluster, maybe it's interesting to go to have structural financing schemes from the Flemish community, and maybe we also can go to the EIB, the European Investment Bank, to show this.
Absolutely. Thank you so much, Roland, for sharing this. I think, as you're saying, this political dimension and I'd say partnering with more people to deliver this message and create the needed either regulatory changes or programs that can specifically support this is very relevant. So thank you so much for that and letting us know also the potential next steps that you're gonna take within this journey. I don't know, we have just maybe time for one more question. If there is anyone from the audience that would like to step in and either mention something from this presentation or from their own experience. please feel free. And if not, as we are reaching the end, I just wanted to thank a lot again Roland, Hannelore, and the whole team for this great example. We're really happy at the Neutralpath project to be supporting you and trying to find opportunities to also discuss with more experts and with other cities, with other examples. We have then just a small announcement. We have a coming public webinar. We will share what just kind of like what we did now with the City of Ghent, but with the City of Zaragoza. This is coming around October, November. We will confirm the date and we will share it with everyone. And then we also have, as was Roland mentioning, also in bundling up with other cities, we have a Neutralpath City Alliance. So besides the 5 cities that we work with, we have an alliance of other cities, smaller cities that are trying to join, like leveraging also on the knowledge that these cities, these front cities are sharing in a way within the Neutralpath project. So we're trying also to build these alliances and spreading the word on these examples and what we can get out of working in a collaborative way. We also have a community of practice trying to share more on the technical aspects of it and also on the business models and all of what we have heard during this day. So I thank you a lot again to everyone. You can join both the City Alliance or the community and follow us also on social media, and hopefully we can keep conversing, we can keep discussing on this very interesting topic and others that come around the positive and clean energy district. So thank you so much for your presence and participation, and see you in the next one.
Thank you. Bye.
Thank you.
Thank you. Bye.
Thank you.
Thank you. Bye.
Thank you so much. Bye-bye.